Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about horizontal tangents.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals a negative x squared minus 4x minus 6, and we want to find the points where the tangent line to this function is horizontal. To do that, we need to first find the derivative. Okay, finding the derivative here, so we're going to find, let's call it f prime of x, and we're going to use our power rule. 2 comes down, negative 2x here, subtract the exponent by 1 is 1, and the derivative of negative 4x is a negative 4, and derivative of negative 6 is, well, 0. And by finding this derivative, we can find the slope of the tangent line at any given point. We want to find where the function is horizontal, so we take this derivative and we set it equal to 0 and solve for what x value comes out there. So we take negative 2x minus 4 and we set it equal to 0. And now we're solving for x. Add a 4 to both sides, and negative 2x equals a positive 4. Divide both sides by a negative 2, and x equals 4 divided by negative 2 is a negative 2 overall. So we have the x coordinate right here, where our function, right, where the tangent line is happening there, but we also want to find the y coordinate. So we go back to our original equation, and we're going to plug in here what y value happens. We plug in, I'm going to put a negative here. Negative, we'll put a negative 2 in for x squared minus 4 times negative 2 minus 6. And it's crucial you plug it into our original function, not the derivative here. We're trying to find the y value there. It happens, well, negative 2 squared is a positive 4, but then we have a negative outside. So we have negative 4, we have a plus an 8 here. 4 times 2 is 8, and the negatives cancel with positive, minus 6. Negative 4 plus 8 minus 6 comes out to be a negative 2. And so we have an x value, we have our y value, so we have a coordinate point of negative 2, comma 2. And that is our final answer. It's the coordinate point where the tangent line to the function is horizontal. We're given this problem right here. Y equals a negative x to the third power plus 3x squared minus 1. And we want to find the points where the tangent line to the function is horizontal. Well, first thing I want to do is find my derivative. Let's go find f prime of x, let's call it. Well, the negative stays out here, 3 comes down, x, subtract the exponent by 1 is a 2. Plus 2 times 3 is a 6, x, subtract the exponent by 1, which is 1. And the derivative of negative 1 is 0. We easily have our derivative here, and we know where we have our derivative equal to 0, that's going to be where the tangent line is equal to, the slope is equal to 0, which is when it's horizontal. So we have negative 3 x squared plus 6x equals 0, and let's solve for x. Well, this is just algebra at this point. Let's pull out a 3x here, and we're left with a negative x plus 2 equals 0. Set both parts equal to 0, and x equals 3x equals 0, and negative x plus 2 equals 0. Here, x equals a 0. This one, subtract the 2 divided by negative 1, and x equals a positive 2. Well, we have our two x values where we know the slope of the tangent line is equal to 0, but they want the whole coordinate point here. So to do that, we have to go back into our original function and substitute these x values in. So let's go call our original function just f of x here, and let's say it's equal to, let's put 0 in, negative 0 to the third power plus 3 times 0 squared minus 1. From there, well, negative 0, or 0 to the third power is 0, negative doesn't matter. Here, that goes to 0 as well. And so we actually have just a negative 1. And whoops, I should have shown this, that this is f of 0. Apologies. Right there. We're now going to do the same thing with f of 2. So let's take f of 2, the other x value, and we're going to plug 2 in for x. So we have a negative, and then 2 to the third power, plus 3 times 2 squared, minus 1. And again, we're seeing what this solves to be. 2 squared is a, 2 to the third power is 8, so we have a negative 8 here, plus 2 squared is 4, times 3 is a 12, minus 1. Well, negative 8 plus 12 minus 1 comes out to be a positive 3. So we have our two y values now that go with our two x values. So our coordinate points here are 0, comma, negative 1, and 2, 3. And these are the two coordinate points where our tangent line to our function is horizontal. We're given this problem right here. Y equals a negative x to the third power plus x squared minus 2. And we want to find the points here where the tangent line of the function is horizontal. Well, to do that, we need to find the derivative first. So let's go find what f prime of x is here. Using power rule, negative, and then with the 3 comes down, x squared, plus 2 comes down times x to the first power, and then the negative 2 disappears there when we take the derivative. Well, now this derivative tells us the slope of the tangent line at any x value. Well, if we want the horizontal line, that slope is 0. So we want to find what x values cause this to be 0. So we have negative 3 x squared plus 2x equal to 0. Now we're just solving for x. Pull out an x here, and we have x times the negative 3, x plus 2 equals 0. And then we clearly said we have two x values, x equals 0 here. And then the inside we solve, set equals 0, minus 2 to both sides, divided by negative 3. And x equals a positive 2/3. So we have our two values right there, our x values, where we know we have a horizontal line as a tangent line for our function. But we want to find the coordinate point. So to do that, we take these points and plug them into our original function. Make sure it's the original function. F of x, not x, we're going to put 0 in for original function. I always do that. F of 0 is equal to a negative times 0 to the third power plus 0 squared minus 2. Well, this is pretty easy. Zeros and zeros just kind of cancel out, and we have a minus 2 left over. Pretty easy. Do the same thing with f of 2/3. Plug 2/3. That's plugging right, yeah. 2/3 in for x. Negative 2/3 to the third power plus 2/3 squared minus 2. Now let's go simplify this out. I did the hard work for you. Negative, or 2/3 to the third power is an 8/27. And that's still a negative. Plus 2/3 squared is a 4/9. Minus 2. And that all simplifies when we add it all together. Negative 8/27 plus 4/9 minus 2 is a negative 50/27. So we have our two coordinate points here, 0, negative 2, and 2/3, negative 50/27. And that is where it's the points where the tangent line of our function is horizontal. We're given this problem right here, y equals 1 over x squared minus 1, and we want to find the points here where the tangent line to this function is horizontal. Now I like to rewrite this to be y equals an x squared minus 1 to the negative 1 power, and that's only because I like taking the derivative of this. And that's really our first step, taking the derivative. So we find f prime of x here. Negative 1 comes down, keep the inside, x squared minus 1. Exponent subtracts by 1, and we have a negative 2. Multiply that by the derivative of the inside, which is a 2x. Or, yeah, 2x. Oh, almost messed that one up. All right, simplifying this now, negative 1 times 2x is a negative 2x. Over here, our x squared minus 1 to the now positive 2 power in the numerator. All right, we have our derivative, and our derivative tells us the slope of the tangent line. And we want to find where this function is horizontal, aka where the slope of the tangent line is equal to 0. So we take our derivative, f prime of x, and it's equal to negative 2x over an x squared minus 1 squared, and we're seeing where it's equal to 0. Well, this is where the knowledge of rational functions is important. Our rational functions here, we know if we're dividing by 0, our function's undefined there, we can't do that. And so really there's nothing the denominator really can do to determine our function if it's equal to 0. So we just have to look at the numerator, negative 2x equals 0, and solve. Divide both sides by negative 2, and x equals 0. And that's the main point we're actually going to be working with. Just to double check that 0 doesn't cause the denominator to equal 0. 0 in the denominator, well 0 squared minus 1 is a negative 1, we're good. And so 0 is the x value where we have our tangent line being horizontal, but we need to find the y value. So we start with our original function, let's call it f of x, put 0 in for x, and we're seeing what the output is. So we have 1 over 0 squared minus 1. And again, make sure you plug it into our original function. Well, this comes out to be, well, 1 over negative 1, which is a negative 1. And so we have a coordinate point here, 0, negative 1. And that is where the tangent line of the function is horizontal. We're given this problem right here. Y equals x to the third power minus 2x squared plus 2. And we want to find the points here where the tangent line to the function is horizontal. Well, the first thing I need to do is find my derivative. We're going to find f prime of x. We're using a power rule. 3x squared minus 2 times 2 is a 4, x to the first power, and we don't have to write anything else afterwards. Derivative of 2 is 0. Well, we quickly found our derivative, and we need to find where this derivative is equal to 0, finding where the tangent line, a slope, is equal to 0. So we take 3x squared minus 4x, and we're setting it equal to 0. And now we're solving for x. Let's pull an x out here. X times 3x minus 4 equal to 0. Set both parts equal to 0. It's just algebra. X equals 0. And x equals, well, add a 4 to both sides, divided by 3, a positive 4/3. So we have our two x values where this occurs, but we need to find the whole coordinate point here. So we use our original function right here, the first function, and we're going to plug in these x values to find the y coordinates where our tangent line of the function is horizontal. So let's go with the first one. We have f of 0. 0 is going in for x here. And we have 0 to the third power minus 2 times 0 squared plus 2. Solving that, pretty easy. 0 to the third power is 0. 2 times 0 squared, 0, 0. We just have a 2 left over. Pretty easy. Let's do it again with the 4/3. So let's go find f of 4/3 here. And we have 4/3 to the third power minus 2 times a 4/3 squared plus 2. Now I did the hard work for you. 4/3 to the third power is a 64 over 27 minus 4/3 squared times 2 is a negative, or minus signs out there, 32 over 9. And we have it plus 2. We add all that up. 64 over 27 minus 32 over 9 plus 2 is a 22 over 27. And so our coordinate points here, combining the x and y value of 0, 2, and we have 4/3, 22 over 27. Should give myself a little more room. It's all right. And these two coordinate points are where the tangent line to the function is horizontal. We're given this problem right here. Y equals a negative x to the third power plus 9x squared over 2 minus 12x minus 3. And we want to find the points here where the tangent line to the function is horizontal. Now, first thing I need to do is find my derivative. So let's go find f prime of x. Let's call it that. And let's use the power rule. 3 comes down. Negative 3x squared here. 2 comes down, right, in the front and cancels out with that 2 in the denominator. So we just have a 9x here, and then minus a 12. Pretty easy to find the derivative there. Now once we found that derivative, we need to find where this function is, or this is the derivative is the slope of the tangent line, and we have to see where it's horizontal, aka equal to 0. And so what we do is we set this whole thing, negative 3x squared plus 9x minus 12 equal to 0. Now, there's a good old quadratic formula that can help you there. We have a great song on that, by the way. You can check it out on our YouTube channel. We're going to use the quadratic formula here. Hopefully you remember. X equals a negative b value, which is 9, plus or minus the square root of b squared, 9 squared, minus 4. A is a negative 3. And c is a negative 12. All over 2 times the a value, which is a negative 3. Let's go find now where it's equal to 0. Let's keep simplifying. X equals a negative 9 plus or minus. Square root 9 squared is an 81. Where are my notes? Let's make sure I'm on the right path here. I'm at 81 here. Negative 3 times negative 12 times 4, or negative 4, we have a minus 144 here. All over 2 times negative 3 is a negative 6. Keep on keeping on here. Negative 9 plus or minus the square root. 81 minus 144 is a negative 63 over negative 6. And this is where the hiccup should happen. What do you notice here about the square root? Well, the square root of a negative number, that's going to be imaginary. So if a square root of a negative number is going to be an imaginary number, we actually don't have a real 0 here. So what does that tell us? Well, that tells us here that our derivative will never equal 0, meaning the slope of the tangent line will never equal 0, which means the slope of the tangent line is never horizontal. So, or the tangent line is never horizontal. And so what we would say here is that there is no horizontal tangent line exists. And so no horizontal tangent line exists is our final answer. We're given this problem right here, y equals a negative 2 divided by an x minus 3, and we need to find the points where the tangent line to this function is horizontal. Now, I know I'm going to have to take the derivative here, but I like to rewrite this function to be something I like to take the derivative of. Negative 2 stays here, and we have the x minus 3 to the negative 1 power. And that's just a personal preference. From here, let's take the derivative. Let's find f prime of x. Negative 2 stays out front, negative 1 comes down, inside stays the same, x minus 3, subtract the exponent by 1, minus 2 now, multiply by the derivative of the inside, positive 1. From there, let's simplify this. Negative 2 times negative 1 times a positive 1 is a positive 2. Denominator, we will bring this back down, x minus 3 here, to the second power. So we have our derivative. This derivative tells us the slope of the tangent line. We want to find where that's horizontal, so we take our derivative and set it equal to 0. So we take f prime of x, which is equal to 2 over an x minus 3 squared. Let's go set that equal to 0. And this one's actually, well, pretty tricky. We want to see where this function is, well, it can be equal to 0 and what x values cause that. Well, the denominator here, there's nothing really we can plug in that causes it equal to 0. The only thing maybe is with denominator equal to 0, which we're divided by 0, it's undefined. The numerator, we actually, well, we can't say the numerator equals 0 because there's no variable. It's just 2 equals 0. It doesn't compute there. And so what does this tell us? Well, this tells us that our derivative, our function that's a derivative, will never equal 0. And what that tells us here, that the derivative is never equal to 0, that means the slope of the tangent line is never equal to 0, meaning our tangent line is never horizontal of our original function. So we would say that there is no horizontal tangent line, if I can spell, exists. And so our final answer here is there's no horizontal tangent line that exists. We're given this problem right here. Y equals a negative 1 over x squared plus 1. And we want to find the points where the tangent line to the function is horizontal. Well, I like to rewrite this function here to be like this. Negative denominator x squared plus 1 to the negative 1 power. And that's because I know I'm going to be taking the derivative. I just like taking the derivative of rational functions like this. With that being said, we need to find the derivative. F prime of x is equal to, negative stays out front, so let's call it negative 1. This negative 1 comes down, negative 1. Inside stays the same, x squared plus 1. Exponent gets raised to the, or subtract by 1, so it's a minus 2 power, times the derivative of the inside, which is a 2x. Simplifying this back out to a rational function, negative 1 times negative 1 is a positive 1 times 2x is a 2x's in the numerator. Denominator, bring down the x squared plus 1, and we now have an exponent of 2. Alright, so we have our derivative here. What we want to do is find where this derivative is equal to 0, because remember, the derivative is the slope of the tangent line, and we want to find where that's horizontal, aka equal to 0. So we take f prime of x, and that's equal to 2x over an x squared plus 1 all squared, we're setting equal to 0. Now the tricky part here is our denominator. Well, we don't really have to worry about that, and that's getting knowledge of rational functions. because if this denominator equals 0, the function undefined doesn't count. So we just look at the numerator, which is 2x, and we're setting it equal to 0. Divide both sides by 2, and x equals, well, 0. Just to double check, plugging it into the derivative here, seeing if the denominator does equal 0 when it happens. 0 squared is 0, plus 1 is 1, 1 squared is 1, we're good. So when x equals 0 is where our slope of the tangent line is equal to 0. So what we need to do now is plug that into our original function to find the y-coordinate there. Remember, it's the original function now. So we have f of 0, plugging it in, equals negative 1 over 0 squared. I can write a squared, oh my goodness, plus 1. Negative 1 over 0 squared 0, plus 1 is 1. We have a negative 1 right here. And so our coordinate point, 0, negative 1, is our final answer, and that is where the tangent line of the function is horizontal. We're given this problem right here, y equals a negative 2x plus 4 to the 1/2 power, and we want to find the points where the tangent line to the function is horizontal. Well, first thing I want to do is find the derivative here. Just find f prime of x, and it's equal to, the 1/2 comes down, we have a negative 2x on the inside plus 4, and we raise the exponent, we subtract it by 1, is a negative 1/2. Multiply that by the derivative of the inside, which is just a negative 2. From there, let's go simplify this a little bit. F prime of x. 1 times negative 2 is a negative 2, over 2 stays in the denominator, and this whole bit right here, negative 2x plus 4, can go down to the denominator, and we have a positive 1/2 power now. Let's cancel some things out. 2's cancel. And so we have an f prime of x is now equal to a negative 1 over, and this denominator is just a square root of a negative 2x plus 4. All right. So we have our derivative right there, and what we want to do now is see, well, where it's equal to 0. Because remember, the derivative here is the slope of the tangent line, and we want to see where this tangent line is equal to 0, aka horizontal. So we take f prime of x, which is a negative 1 over the square root of negative 2x plus 4, and it's equal to 0. We're trying to find when it happens. Well, here's the tricky part. Our denominator, it can't equal 0, because the denominator equals 0, we're dividing by 0, it's undefined. And there's nothing else that actually would cause this equal to 0. Because the numerator, right, can't just equal 0, there's no variable there. So we actually don't have a place where our derivative is equal to 0. Okay, and what that tells us is that there's no point where the tangent line is horizontal of our original function. And so we would say that there is no horizontal tangent line exists. And so our final answer here is no horizontal tangent line exists. We're given this problem right here. Y equals a negative cosecant of x on the interval from negative pi to pi, and we want to find the points where the tangent line to the function is horizontal. Well, first thing we want to do is find the derivative here of our cosecant. So the f prime of x here, the negative stays out front, so let's call it negative 1 here. And the derivative of cosecant x is a negative 1, or negative cosecant x cotangent of x. Now we can simplify this a little bit more. F prime of x, negative 1s cancel each other out or multiply to be positive 1. And so we have cosecant of x and cotangent of x being multiplied. There. Now this is where it becomes tricky. We can set each one now equal to 0, because remember, we want to find where the tangent line of the function is horizontal, where the derivative is equal to 0. Since there's multiplication here, we can see where cosecant of x is equal to 0 and cotangent of x is equal to 0. So let's write that out. Cosecant of x is equal to 0, and then cotangent of x is equal to 0. Now, one thing we know about cosecant of x is that it never is equal to 0. So we actually don't have to worry about that. We won't have to worry about where cotangent of x is equal to 0. Cotangent of x equals 0 twice, if we remember this. Happens twice at x equals negative pi over 2 and pi over 2. Now, when I say twice, it's within our interval of negative pi to pi, right? We know it hits infinitely many times, right? But within the interval, it's from negative pi over 2 and pi over 2. So what we're going to do now is find the y values of that, of the x values there. Because remember, these x values are where the function's horizontal, and the tangent line's horizontal, and we want the coordinate points. We need to find the y value. So we use our original function up here, and let's do negative pi over 2 first. Is a negative cosecant of a negative pi over 2. We're going to do the same thing with pi over 2. And for x value, negative cosecant of pi over 2 here. And what do they equal? Well, the negative cosecant of negative pi over 2 cancels out the negatives, and we have a positive 1 there. The negative cosecant of pi over 2 is a negative 1. And so with that, our coordinate points here are negative pi over 2, comma, a positive 1, and a pi over 2, comma, a negative 1. And these two coordinate points are where the tangent line of our original function is horizontal. I hope this video is helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.